Humoral immunity is an indirect method of defense. Instead of directly attacking enemy cells, the B lymphocytes of humoral immunity produce antibodies, which are also known as immunoglobulins. They bind to antigens and tag them for destruction by other means. Humoral immunity works in three stages: recognition, attack, and memory. An immunocompetent B cell has thousands of surface receptors for one antigen. B cell activation begins when an antigen binds to several of these receptors, links them together, and is taken into the cell by receptor-mediated endocytosis. In most cases, a helper T cell binds to the complex and secretes interleukins that activate the B cell. This triggers clonal selection of the B cell. Most cells of the clone differentiate into plasma cells, and about 10% of those remain in the lymph nodes. But the rest leave the lymph nodes and end up in the bone marrow or elsewhere. There, they produce antibodies until they die. These antibodies travel throughout the blood and other body fluids. Antibodies are defensive gamma globulins which are found in the blood plasma, the tissue fluids, body secretions, and some leukocyte membranes. The basic structural unit of an antibody is shown here. Once released by a plasma cell, antibodies use four mechanisms to render antigens harmless. The first is neutralization of the active regions of an antigen. Second, complement fixation, which exposes the antigen's complement binding sites and initiates the binding of complement to the enemy cell surface. The third one is agglutination. This is where the antibody binds to antigen molecules on two or more enemy cells at once, causing them to stick together. And finally, precipitation, in which the antibodies link antigen molecules together, creating antigen-antibody complexes that are too large to remain dissolved in solution and can be removed by immune clearance or phagocytized by eosinophils in the connective tissues.